Hello and welcome back to 13.3, the base E. Today we'll be going over explain 1, graphing combined transformations for f of x equals e to the x power. Just so you know, e is a natural number. In fact, if you actually plugged into your calculator and you're like, what is the e value actually representative of? It's actually a decimal, and I'm just giving an estimate of 2.71828 so it's a pretty long number. It's actually much like it's actually similar to your pi value that you're more familiar with of 3.14. Now I know there's a lot more numbers that come after that, but that's another natural number that you can that you're learning about. So according to this example, they're asking us to identify the reference points, use them to graph, state how the transformations are made. So it's going to look a little different from our parent function f of x equals e to the x power, and of course to write the domain and range. So the first thing we're going to do is identify our a value, our h value, as well as our k value. So our a value is 3. As you can see here, x plus 1 is not in the format of x minus h, so we're going to rewrite that as x minus negative 1, because negative times a negative is a positive 1. So our h value is really negative 1. And our k value is going to be 4. We're going to use these values to find our reference point. So our h value is negative 1. And we'll add together 3, which is our a value, plus our k value of 4 to figure out our first point. So take some time to simplify that out, and that would be 7. The next part here would be our h value, which is about negative 1 plus 1. And then our a value, which is 3, our e, which is our natural number, plus our k value. So let's simplify that out. That would be about 0, 3e plus 4. So we're going to use these two reference points to graph. So let's go on to the next slide. So from our last slide, we know that our h value is negative 1, our k value is 4, and our a value is 3. What that h value is going to tell us is it's going to tell us how many units, which is 1. And since this is a negative number, are we going to go to the left where all the negative numbers are on our line, on our x value line, or to the right where all our positive values are? To the left. Also make a note of this in your example problems if this is helpful to kind of when you have to fill in the blanks, because I'm not going to do every single problem for you. Go ahead and write this down. For our k value, the graph is going to translate 4 units, because that's what we got, 4 units. And since it's positive, will we go up or down? Again, write this in if this helps to kind of fill out the blanks for yourself. But since it's positive, we'll be going up. And then our a value of 3 means that our graph is going to vertically stretch by a factor of 3. Alright, so we identified our reference points. We stated the transformation and how that's going to change. We still need to identify our isotope, our domain, our range, and let's not forget that we also have to graph. So on the next slide, we'll go ahead and figure out what our k value is. So our vertical isotope. So our k value we found to be 4. Okay, and as you can see, they kind of graph those points for us, which is kind of nice. Negative 1, 7, just graphed there, and 0, 3/4. Okay, and if you're wondering, well, how did they know it was about 12? Well, what we could do is we can actually calculate that out. So 3e is about 8.1 plus 4, which is about 12.1, so that's pretty close. And they already graphed our isotope for us as well. So remember, our domain is all of our x values, and it looks like we can have negative numbers for our x value and positive numbers, which is kind of cool. Now we could write a sentence all negative and positive numbers, but there's a mathematical way we can use that. Again, that negative infinity sign, positive infinity sign, and x could be any number in between. For our y value, there is a limit. In fact, like limbo, how low can it go? It looks like the lowest value that it can go is about 4, and in fact, that's a line that it will never cross. Even though I know, yeah, it looks like it's touching, that graph actually will not cross that y value of 4. So that means y can be all numbers that are bigger than 4, like 5, 6, 7, 8, 9, all those numbers that are greater than 4, but not actually touching 4. Okay. Well, moving right along, let's go on to explain B. Again, let's take some time to identify our A, H, and K value. So our A value is about negative 0.5, our H value is about 2, and our K value is about negative 1. So let's go ahead and use those values to try this out. So that would be 2 comma negative 0.5 minus 1, because that was my K value. And here that would be our H value of 2 plus 1, our A value of negative 0.5 times E plus our K value of negative 1. So let's go ahead and take some time and simplify this out for this value here, and then for this value here and here. Okay? So if you calculated that out, that would be about negative 1.5. That would be about 3. And this would be about negative 1.3 plus a negative 1, which would end up being a negative 2.3. Alright, so we identified our values. We found our reference points. We are now going to write down our H, K, and A value. Our H value was 2, negative 1, and 0.5. So it's 2, negative 1, and I believe that was negative 0.5. So again, let's use some of those notes from part A to work out what we'll do for our fill in the blank. So we're going to decide if we're going to go left on the negative side or right, up, or down. And then for here, I know the last time we used a stretch. So stretch is when it's a whole number. If we get a decimal or a fraction, then it will be a compression. So think about when you stretch, things kind of get a little bit wider, whereas compression means things get a little bit more pushed in. Okay? So here for our H value, since it's a positive, we're going to go 2 units to the right. For our K value, since we're going 1 unit, since it's negative, we'll go down. And here, since we did get a negative decimal, well, decimal nonetheless, it's going to be a compression. So whether it's negative or positive doesn't really matter. It's more of, you know, do I get a whole number or do I get a decimal? Remember, stretch is if it's a whole number, and a compression is if it's a decimal. And that's at about 0.5 negative. Okay, so you'll notice when we're starting to graph this that our A value is negative. In fact, it's a negative 0.5, so that means it's going to reflect over our x-axis. So essentially our graph from the part A kind of looks something like this. So maybe for part B it'll look a little bit like the reverse over our x-axis, just to give you an idea. So our isotope is a vertical shift to y equals k. On our k value, just to make sure, it was our -1. So I'm going to go ahead and find -1 on our y-axis and kind of draw my vertical isotope. It's a sketch, and I'm drawing on the screen, so it's a little not too straight, but it's about there. And then our reference points were 2, -1.5 and 3, -2.3. Alright, so let's go ahead and plot those points out. It's 2. Now I notice here that they don't really give me my middle values, so I'm thinking that's about 0.5, 0, -0.5, -1.5. So this sometimes helps to kind of help us graph along the way. So here for 2, -1.5 would go here, and for 3, -2.3 would maybe go somewhere around here. So I'm just going to kind of sketch my graph. I know my line will probably start here, go up, and get really, really close, but never actually approaching our y value of -1. So remember, our domain is all of our x values here. And remember, our x values can be positive numbers and negative numbers. So that's kind of cool. And we learned the fancy terms for those. Negative infinity and positive infinity. So it could be any number in that area. But our range seems to hit a limit. Our highest value, so the opposite of limbo, kind of our maximum value, is about -1. And that's all the numbers that are actually less than -1. So that's less than -1. Alright, go ahead and stop here and try out the Explain 1 problem in your packet. And we'll go on to the next section.